The next task in the hands-on workshop is the clustering task using the k-means algorithm. Again, we will refresh the data from the database using the OML cast data frame. And as the k-means is meant to be used for a lower number of attributes, and this is the way it should be used for clustering purposes, I'm going to keep only two columns in the data frame, the customer ID to identify the customers and the LTV numerical value of the lifetime value of the customer. So I'm going to run this, and here are the two columns I'm going to use for the clustering purposes. In the end, when I will compare the results with my existing data and my existing information, I'm going to use the classification labels from the LTV bin column to compare the clusters identified by the k-means algorithm and by my data machine learning model. I'm going to merge this the results. In this case, I have the columns with the values of the four classes we have identified in the LTV bin. I'm going to split my data frame into train data and test data, and I'm going to use the default split ratio, and then I'm going to return the shapes of my two splits here. So again, I'm using 10,000 rows for the for training and 4,500 for testing. And I'm going to specify the iterations for the k-means algorithm to be used when I create the machine learning model. In this case, it's 20. Actually, this is the default value for the algorithm itself. I'm not changing anything, but just to show you how to specify settings when you create a k-means model. And then I'm going to create the k-means model object and train it with the training data using the cast ID column in my data frame to identify individual records for my cases. So, and the number of clusters in this case, I'm going to specify 4. I just want to make to check if there is any correlation between the clusters identified by this k-means machine learning model and the human and the classes we have defined by a business user in the LTV bin column. Let's create the model, the machine learning model, and then let's check the definition of the model. So in this case, we have a clustering model using the algorithm k-means, and the number of iterations is 20 in the settings we have specified when we created the model. It has converged after 20 iterations, and here we have the clusters and the other attributes and details of the model. And now we are going to use this model on the test data set to make the predictions and to identify the clusters for this data. And then I'm going to add the supplemental columns just to be able to compare the results of this execution. So you can see here, 4 clusters have been identified. They have the different IDs. They have the IDs 3, 5, 6, and 7. You can see those clusters here in the model definition. the cluster ID 3, 5, 6, and 7 in the previous execution of the Python code. And we can also see how many customers from my data set have been placed in those 4 clusters. The count here of the records in each one of the in each one of the clusters. So I'm going to merge now the data set, the full data set, with the clusters we have identified, and I'm going to use the cluster ID, the customer ID, to identify individual records, and then I'm going to compare the clusters with the classes we have in the pre-labeled LTV bin column. So let me run this and see that, for example, high customers are in cluster 7, but we also have in cluster 6. Very high customers we have in cluster 7, and medium we have in 5 and 6. So there is maybe a correlation between the clusters produced by the K-means algorithm and the classes which have been defined by a human operator in our pre-labeled data. We can build a summary just to count the members in each one of the clusters. And here we have based on the predefined classes. So on the low class, in cluster 3, we have 185 customers. And from the low customers, in cluster 5, we have 254 customers. Then medium customers, 960 are in cluster 5 and 478 are in cluster 6. And then in high customers, yes, in the high class customers, we have 1,700 customers in cluster 6 and 452 customers in cluster 7. And very high customers, they are only in cluster 7, 446 customers. So you can see here, there is a relationship between the classes we have in our data set and the clusters that have been defined by the K-means algorithm. And now we can use the plot to understand how these customers have been clustered and what is the relationship between the classes and the clusters they have been identified. For the more exactly, in this case, we are using the LTV numerical value. You can see here the 4 clusters. There, I use different colors for the 4 clusters. So this is cluster 1, 2, 3, and 4. The idea of the cluster is 3, 5, 6, and 7. So these are the clusters identified by our model. And here are the values of the long lifetime value, numerical values that our customers have in the data set. And you can see here the values of the lifetime value, they more or less correspond with the clusters. You can see here our customers have been clusterized in 4 clusters, have been split, let's say, in 4 clusters, and there is more or less a relationship between their exact lifetime value and the cluster in which they belong to. And we can also use a scoring function to return the score of this.